Hi guys, I would love to take you on a journey on how you can go about solving limits. Limits. It's not difficult. Now, I have a video already, previous video, on what limit is all about, definition of calculus and all that. Lay your hand on it. All right. Let's go about how you can approach limit. Yeah, you have this question: limit as 3x raised to power 2 minus 1 over 2x plus 1 as s tends to 0. In some other textbook, you write limit like this. It's the same thing. All right. How do you do this? In this case, there's nothing you can do, no algebra, you can't factorize. So you can afford to plug in as the value of s tends or approaches 0 directly. So we have limit 3x is 0, right, raised to the power of 2 minus 1. We call this direct substitution. Direct over 2 into 0 plus 1 as s tends to 0. That's why we're having 0 here. This is equals to what? 3 times 0 to the power of 2, 0 times 3. That's give us 0 minus 1 over 2 times 0, 0 plus 1. So I have minus 1 divided by plus 1, which is equals to minus 1. That is the answer. I hope it's simple, right? All right, let's look at more examples. We have limit all right, x squared plus x as x approaches 0. How do you go about this very one? Look at this. In this case, it's not like the first one I just did. Don't plug in the value of as s tends to 0 directly into this. There's something you can do to this question. You can factorize. So let's say by factorization, yes, this is direct substitution. This is by factorization. We have limit, right, x raised to the power 3 minus x. What is common there is x. Bring that x out. This becomes x raised to the power 2 minus 1 over, you also factor out, we have x plus 1. Right? Now look at this. As s tends to 0. All right. Look at this. This s can take care of this x here. And look at the numerator here. Remember the difference of two squares. A raised to the power x minus b raised to the power x. This can be expanded as a plus b into a minus b. Expand this to give you this. This is also of that form. Now 1 is squared. You have s squared minus 1 squared will give us s plus 1 into x minus 1. Right? Nice. I hope you're following me. Now we have limit as this become x plus 1 into x minus 1 on x plus 1, right, as x tends to 0. This takes care of themselves there. So we have x minus 1 left. Remember that s tends to 0. So this becomes 0. So we have 0 minus 1, which is equals to minus 1 as the answer. Our answer is minus 1. Right. Look at the procedure. So what do you do first when you have a question that has to do with limit? You look at, can I do a little bit of algebra there? If the answer is no, that's when you apply direct substitution. If the answer is yes, work on it before you go by the value of x approaches 0 or whatever it approaches. Let's look at more questions. Here, how about having this kind of questions? You have limit s squared plus 3x minus 10 on s squared minus 2x. Now, as s tends to 2. Yes, like I said, what do you do with this? It's factorizable. So like the second one I did. So we can have, you're looking for the two factors of the constant that will give you minus 10 when you multiply. And when you add the same two factors, it will give you 3 in the middle. What do I mean? I have 10 here, 2, 5, 5. So this can give me 2. The two factors are 2 and 5. 2 times 5, 10. So let me assign the sign. If I have minus 2 plus 5. Minus 2 times plus 5 will give me minus 10. Then minus 2 plus 5 will give me plus 3. So these two factors, I'm good to go. So I have limit as s squared minus 2x plus 5x minus 10 over, factorize this as well, bring out the x minus 2, right, as s tends to 2. As s tends to 2. Let's go factorize this. What is common here? X here. So I have my limit. Bring out x into x minus, right, 2. What is common here? 5, 5. I have plus 5, open bracket, x minus 2. Then on x into x minus 2, right? As s tends to 2. Okay? As s tends to 2. We have, let's do our work completely. Here, x minus 2 into x plus 5, right? We have x into x minus 2 as x approaches 2, right? If you are conversant with factorization, this is simple. Now what do you have here? This going to this, I am left with x plus 5 over x. Remember, x approaches 2. So this becomes 2 plus 5, this becomes 2 over x down here, 2, which is 7 over 2. Final answer. Right? I think I can give you more questions. Yeah. Let's also look at question number 4. Limit x minus 5 over root x plus 4 minus 3 as x approaches 5. As x approaches 5. Now, let's look at this. What's the nature of this question here? As you can see, this is so familiar with this. Having radical in the denominator and is not permitted. So we can do what we can first to find the conjugate of this denominator and clear the radical from the denominator, right? How do we do that? you find the conjugate of this. And in finding the conjugate, all you need to do is to multiply this with the conjugate, and the conjugate is plus here, plus. Multiply the conjugate with both the numerator and the denominator. So what is the conjugate of root x plus 4 minus 3? The conjugate is root x plus 4 plus 3. So I'm going to have limit x minus 5 times the conjugate x plus 4 plus 3 over root x plus 4 minus 3 times the conjugate x plus 4 plus 3. Is that okay? Now this is the conjugate of this. So multiply the conjugate with both the numerator and the denominator. I have this. As x approaches 5, all I need to do now is to multiply, because our aim is to get rid of the radical in the denominator. Okay, if I multiply that, this square root times this square root will give me, this is equals to limit 5 x minus 5 into root x plus 4 minus 3 over this times this will give me x plus 4, the bracket, this square root, this times this 3 will give me plus 3 root x plus 4. Then I'm done with this. This time this will give me minus 3 root x plus 4. Then this time this, it will become minus 9. Minus 9. Remember, look at this. You understand how this time this, I got this. Look at it. If you're familiar with indices, root x times root x will give you root s squared. And what is root s squared? Is root to the power of 2 raised to the power of half. This square, root sign, becomes half there. Then divide this, you are left with x. Meaning that root x times root x will give you x. It's the same thing here. Root x plus 4 times root x plus 4 will give you x plus 4. Right. If you do that, if you look at it this way, this and this, they are the same. So they have alternate sign. So they take care of themselves. It's like a minus a is 0. So I have, as s approaches 5, now limit x minus 5 into root x plus 4 plus 3 on this has gone. I have 4 minus 5. I mean 4 minus 9 is minus 5. So I have x minus 5 as x approaches 5. Yes. At this point, I hope we are together. This divide this. Yes, we are left with what we have here. Remember that x tends to 5. S tends to 5, or s approaches 5. So we're going to have replace this with 5. At this point, we can now substitute in there. So limit here tends to, we have it will become root 5 plus 4 plus 3. All right, which is equals to root 9 plus 3. What is root 9? 3 plus 3, which is equals to 6. Final answer. Right. Just follow it carefully, and it's simple to go. I've been able to solve quite a handful of questions here. Now, can I solve one more? I plan to, so that if you are confronted with different kind of questions that have to do with limit, you know how to go about it. It's simple. All right, let's look at this. Limit 3 plus 3x over 1 plus 1 minus 1. Question number 5. How do you get this? Limit as. Now, look at the nature of this question. We have this numerator, and the denominator is still a fraction. All right, so you need to work a little bit here. Find the LCM here. So this, we have limit 3 plus 3x over, find the LCM. What's the LCM? X. Let's go to x, 1 times 1 plus 1 goes to x times 1. X this way as x approaches minus 1. All right. Now, what does this one mean? It means 3 plus 3x divided by x plus 1 plus x over this equals to 3 plus 3x. Change the sign times x goes up. This comes down. I hope you're familiar with simple rule of fraction. If I multiply, I'm going to have 3 plus 3x multiplied by x. Don't open the bracket yet. Over 1 plus x. Yes. We're taking the limit of this right now. Limit as s approaches minus 1. Right? With this, you can look at the question here we have here. Again, you can factor out this equal to limit as s approaches minus 1. I can factor 3 plus 3x, bring it out here, becomes 1 plus x. Then this x behind over 1 plus x. Yeah. So this and this is the same. To correct themselves there. What do I have here? I have 3 times x. Alright? And also remember, as x approaches minus 1. So I'm going to have 3s is minus 1, which is equals to minus 3. Final answer. Please, I don't need to, I just want to remind you, if you love what we are doing, just like it and subscribe to the YouTube channel for more interesting tutorial like this. Number 6. You are given a question that has to do with limit s squared minus x plus 4 over x 3 plus 5. Now, the value of s here tends to infinity. Yes, I've almost forgotten. Tends to infinity. This is not 0, this is not 1, this is not 2. How do you handle it? Once you notice that it's to infinity, right? Now, divide every single expression here with the highest value of the variable, with the highest variable that has the highest power. Yeah. What do I mean? The highest power here is 3. So I'm going to divide this, all of this with s to power of 3. Yeah. This is limit. We have s squared. Yes, we have s squared divided by 3 raised to power 3. I mean s raised to power 3 minus x divided by s raised to power 3 plus 4 divided by s raised to power 3 all over s3 divided by s raised to power 3. Alright, plus 5 divided by s raised to power 3. As x tends to infinity. This is how you go about it. Once the function of x is to infinity. Now we have this. If I have this, I'm going to have limit. Alright, s squared divided by s to the power 3. It will give me 1 over x. Right? Minus This will give me 1 over s squared. Then 4 over s raised to power 3 over, this will give me 1, right? Then plus 5 over s raised to power 3. Are you with me? As s tends to infinity. What do I have here? Now, when it tends to infinity, you're going to substitute in here now. That the value of s is to infinity. So 1 over x becomes 0. If it's x under, it becomes 0. So we're going to have limit as s tends to infinity. We have 0 minus, this is 0 plus 0, as long as it's x under, which tends to infinity, over 1 plus 0. What do I have here? I have 0 over 1. And 0 divided by 1, the answer is 0. Is that right? Any question given to you and the value of x or whatever the function is tending to infinity, divide all the expression you have by the highest power of the variable. Yeah, do well to like this, subscribe, hit the notification bell for more tutorial like this. Thank you.